Cool. So the next point is determining the significance level. The significance level, in its simplest term, is the probability of rejection and rejection of the null hypothesis. The technical definition of it is the maximum allowable probability of rejecting a true null hypothesis, which we also call as a type 1 error. So we say that alpha, or the significance level, is just the probability of committing a type 1 error. And in our question, when alpha is not provided or not given in the question, we use a default value of 0.05, that is 5%. Now, in determining the test statistic, which is a test step in hypothesis testing, first we need to know whether the population variance has been provided. If it has been provided and the population is normally distributed or approximately normal, okay, then we make use of the set statistic. Now, let me mention the focus of this slide is to look at test on one single mean. Hence, we are limiting ourselves to the tests of or test statistics appropriate for the test of one single mean. Good. So in the case where the population variance or the population standard deviation is provided, you would use the Z statistic, which is defined as the observed mean minus the null mean or the claimed mean over the standard deviation divided by the square root of n. Now the denominator sigma over the square root of n is also termed the standard error of the mean, the denominator. Good. Now, in the case where the population is normal, but the population variance is unknown, then we have two cases. The first case is where your sample size is large, that is, n exceeds 30, that's greater than or equal to 30. Then, based on the central limit theorem, we can equally use Z, that's the Z statistic, with the same formula, but sigma in the formula, in the original formula, will be replaced with the sample standard deviation, which is S. Why S? Because the population standard deviation is unknown. Now, case 2, where your sample size is less than 30, then you fall on a different statistic, which is the T statistic. And the T statistic has the same formula. The only difference between the Z here and the T here is the reading of the critical values from the standard tables. Now, types of test and rejection. This will help us to know where to plot our decision rule. Now, in determining your decision rule or your critical values, you first have to look at the sign on the alternate hypothesis. If the sign is a less than, like we said earlier, then it is a left direction, which means we have a left region rejection, or what we call as a one-tail test to the left. And then if we have mu greater than the test value mu naught, then we have the rejection on the right side, or a one-tail test to the right. And if we have mu not equal to, like I said earlier, not equal to means could mean less than or greater than, which means we have a two-tailed test, and your rejection will be splitted half on the left and then half on the right, which means that your alpha, which is the total probability of rejection, will be splitted into two. So if alpha is 0.05, then half of it will be 0.025 on the left and the other half 0.025 on the right. Let's take an example for demonstration. Test on single mean. A random sample of 1,000 iron rods recorded showed an average length of 71.8 centimeters. Assuming the population standard deviation is 8.9 centimeters, does this seem to indicate that the mean length of iron rods is greater than 70 centimeters? Use alpha equals 0.05 significance level. So here, the concern which we want to investigate is as to whether the mean length, the average length, okay, mean length of rods is greater than 70. Mean length is greater than 70. So in step 1, if we have to write our hypothesis, then it will be what? Mu, which is the mean length, is greater than 70 centimeters. This is the claim. So mu is greater than 70 centimeters. Then the second step is to write the opposite statement guided by the table earlier provided. So that will be mu is less than or equal to 70 centimeters. Then again, your final step is to determine which is the null and alternate. And that will be decided based on the equal to sign. So since the first statement has the equal to, which is the null, and since the claim does not have an equal to, it is the alternate. Step 2 is to state your alpha value, which is being provided as 0.05. Step 3 is to decide the test statistic. And like we said, in a question you have to ask yourself, has the population standard deviation or population variance been provided? So let's go back to the question and check. It says a random sample of 1,000 iron rods recorded showed an average length of 71.8. Assuming the population standard deviation is 8.9, which means that the standard deviation has been provided. So we proceed to apply the Z statistics, assuming the population is normal. So that is Z equals to x bar minus mu over sigma divided by the square root of n. Then in our step 4, we will take sample to calculate for the Z value, that's the Z calculated value. So the sample mean from 100,000 iron rods was 71.8 centimeters, which we substitute into the formula. Then the test statistic value is 70 centimeters, so we have 70 over the standard deviation of the population is 8.9 divided by the sample size square root of 1,000. And once we calculate that, we get 6.3965 as our result. Now, what is the next step? We need our decision rule, which we will use a critical value approach. So in reading your critical value, you have to go to the Z table, meaning first we said the alternate hypothesis. Let's go back briefly. Our alternate hypothesis is mu is greater than 70 centimeters, which means a right hand test or a right tail test, also implying the rejection will be shaded on the right side. Okay, so we have the rejection shaded on the right side. Now, how do we also find the critical value? You go to the standard normal table. Let's see if we can locate the table. So once we read the standard normal table, you get 1.645 as your critical value. The critical value is, let me say, like a threshold value. In other words, when you exceed the value, then you have to reject your null claim. Now, looking at the calculated value, the Z calculated value, we had 6.3964. When we map it on the graph, you realize that it will be on the right side of the critical value 1.645, which suggests that the information from our sample lies within the rejection region. So we say that the test statistic is in the rejection region, hence H0 should be rejected. So we can conclude by saying that at a 5% level of significance, there is enough evidence to reject the null claim. We have enough evidence to reject the null claim, meaning that the mean length of rods is greater than 70 centimeters. In other words, when we reject the null hypothesis, then we accept the alternate hypothesis. Let's take a second example. MTN telephone company claims that the average length of phone calls is 8 minutes. In a random sample of 58 phone calls, the sample mean was 7.8 and the standard deviation was 0.5. Is there enough evidence to support this claim at alpha 0.05? Now, what is the claim? The claim of the telephone company is the average length of phone call is 8 minutes. So we write it mu is 8 minutes. And the opposite statement will be mu is not equal to 8 minutes. Then since the first statement has the equal to, it is a null, as the claim is the null, and the alternate is the not equal to statement. Second step, of course, is to state your alpha level. Third step is to decide which test statistic to use, whether Z or T. Now, in this question, we realize that the standard deviation provided was for the sample. It says in a random sample of 58 phone calls, the sample mean was 7.8 and the standard deviation is 0.5. So this standard deviation is for the sample data. Okay, so we don't have the population standard deviation. But we also know that the sample size is greater than 30, that it is large. So we still go ahead to use the Z statistic, replacing the standard deviation, population standard deviation, with the sample standard deviation. So we have x bar minus mu naught over s divided by the square root of n, which when we substitute and calculate, we get negative 3.05. Now, in our decision rule, like we said, you look at the sign on the alternate hypothesis. We have mu is not equal to 8, meaning we have a two-tailed test. Two-tailed test means we have rejection on the left and rejection on the right. So once we plot it, we have two rejection regions. Then we will have to read the value of Z with probability 0.025. Why 0.025? Because the probability of rejection has been divided into 2. So once you read from the statistical table, the standard normal tables, you get Z value to be what? 1.96. And since the graph is symmetric, you get the other side to be negative 1.96. Now mapping the Z calculated value on the graph shows us that negative 3.05 will lie in the negative, on the left side of our negative critical value. Hence, we say the test statistic falls in the rejection region. So H lot is to be rejected. So we can conclude or decide that at a 5% level of significance, there is enough evidence to reject the claim that the average length of phone calls is 8 minutes. I hope you've understood the concept of test on one mean with these two examples. I wish for your comments and for your questions so I can address them. Thank you for listening.